Adams, CEO of Powercalc. I'm here with James Khalil, inventor of Powercalc, and we're here to show you today not only RAM that's in real time, but also to show you how this Powercalc and the one-line work in an actual design project. So I'm going to turn this over to James. I would say first, we have two video sites, powercalc.co. These deal with a renovation project, a renovation of a school for the Broward County School District, an elementary school. Today's session, we're going to residential high-rise, mid-rise residential building. So I'm going to turn this over to James and we'll get going. Thank you for joining.
Good afternoon, everybody. My name is James Khalil. I'm going to guide you through Powercalc today. And this time we selected the mid-rise building to talk about the capability, one of the capabilities of Powercalc. The Powercalc, the inception of Powercalc actually started with the idea of having a higher quality design and as quickly as possible, and to meet the code requirement, so it follows the NEC requirement. The concept is always going to be from bottom up. You start from to the load. So we're going to go ahead and start this project. The project name is Middle River, and it's I think it's a 2-story building and has a 10 apartment units. So I'm going to go ahead and open this project. What you can see right now here is the setup of the project. So it has one main distribution panel, and the electrical panels, which is indicated here with the blue light, the blue color panels, apartment in that complex. So if I open that panel now, 201, again, we had to go ahead and pre-fill that panel with the circuits for the time's sake, I guess. As you can see here, the panel, the number of the apartment. Underneath it, you see that this is a new panel to indicate to the user that it is a new project. It's not an existing condition. If you click down on the pull-down menu, you have a selection of existing or modified, or there was no nameplate or whatever. So it's just a documentation of what is existing or being new. Underneath it would be fed from. Again, once you build up your power distribution system together, you can have a pull-down menu and you can go ahead and select is fed from. For our application here, it's fed from MDP, so we selected MDP. We input some circuits, which is typical for the residential. And one of the reasons that I wanted to start this time here, there was a lot of questions and a lot of comments came to us in reference to residential. In order for us to take advantage of the code requirement or the code demand factors, the residential has to follow a certain criteria in the code. Basically, the code dictates on you on the number and the type of receptacles in the facility. One of the requirements for a residential is what we call them the small appliances receptacles. And here we depicted them by a kitchen receptacle. So you see circuit number 1 and number 3, it have the 2 small appliances circuit. And then we added the dishwasher, garbage disposal, a range, a refrigerator, and then the air conditioning equipment. My recommendation when you input what we will have a building equipment worksheet. This way you can also have the actual requirement on the worksheet, and then you can link it to any panel you want to. So I'm going to open that worksheet to show you what I'm talking about. So if I click on this particular here, this load, it opens the worksheet associated with the condensing unit 201. In here, you specify the voltage with that piece of equipment, and then you input the criteria. This air handling unit is basically the blower fan And what we're using on this project is a heat pump for those that are working, because we don't really have a big demand on heating as if it is in the north. But if you have a heating associated with the unit, you can go ahead and input that. But this is here, what I input is the full load current from the manufacturer's cut sheets is 28.3. I don't know if everybody can see that or not, but I'll go ahead and enlarge it a little bit. So it's 28.8 amps. The system after that will calculate everything for you based on the indices. So I'm going to take this out and show you how to start the calculation. So right now, all we input is selected the voltage, and it's a single phase. And then I'm going to go ahead from the manufacturer cut sheets, put the full load amp, which was 28.8. I want you to notice what's going to happen here under the electrical load cell. So enter and then calculate. And went ahead and selected for the cooling cycle. That system is going to be 28.8 force, and the cooling cycle kVA is 6 kVA. After you do that, you go ahead and select where is it fed from. So again, I can take that out and I'll show you how to do that. So now fed from, it says select. So I'm going to go ahead and click on the pull down menu, and you select the panel that is going to be fed from. It will give you a list of all the available. So I'm going to go ahead and select the 33. Now, if I go back to this panel 201, there's two ways to do that. Either I click on fed from, or I can go back to the control panel and click on panel 201. And it will get me to that panel. It's going to open it up in a second. And if we zoom back in and go to circuit 33, here is circuit 33, and here is the condensing unit, and here is the trip amp for that particular circuit, for that particular load, and also the circuit conductor associated with it. It's 1, 2, number 8, and a number 8 ground in a 3/4 inch conduit. The other top is 3% voltage drop. In order for you to maintain that 3% voltage drop, you can travel with that distance, with that circuit, 139 feet. If you go over that, you're going to be exceeding the 3%, and I'll show that later on. So now we loaded the mechanical equipment, and I showed you the building equipment input data sheet. Now, the other part of the air conditioning would be the air handling unit. Again, you can do it the same way by going into a building equipment, or you can actually do it directly on the panel. So again, to show you the variety and the flexibility of the system, I indicated in here that it is shown or input the value directly on the panel schedule. So it's air handling unit number 1, and so we show you how it's done. Okay, so now the load is done, is out. Now, for any particular circuit, all I need from you is 3 things: is the load itself in kVA, and then the number of poles down here, which you can select from the pull down menu, and the type of load, which also you can select from the menu. So this is an air handling unit, and I go ahead and input the 2 kW in the first pole, and then the system will take care of it and divide it on equally on the number of poles. And since we have 2 poles in here selected, it divided the 2 by, so now it's 1 and 1. And another thing that is available for you is the options available for the type of, for the circuit breaker. The code requires you nowadays, I think it came, the mechanical equipment has to be associated with an HACR type circuit breaker. So we have all these options in here. If I click down on the options, also you can see a slew of options in here: the HACR, low voltage shunt trip, switch duty rated, and so forth. And also there's two places in here that you can input your own options, and it will be available for you to select it. And I'll show you how to do that in a little bit. Small appliances, we input the range and the other receptacles, smoke alarm, and that sort of things. Now, these particular apartments or these particular units have kind of a unique equipment associated with it. As you can see on circuit 28 and 30, it has an electric car charger station. They promoting, I guess, environmental and green design. So actually each unit has two parking spaces, a regular parking space for a regular car and another one for the electric cars. It has other I guess, higher end type equipment, a wine cooler, an electric grill out on the balconies and so forth. So now it's required by the code. Now, one thing you might notice here that I have assigned the load type, the McLoad, to all the loads in that particular unit to an R. The reason for that is to, again, take an advantage of the demand load calculations that is design this panel for the actual connected load. The actual connected load will come up to be about 66.7 at 0.9, so it's about 67 kW. But you see here, it's demanded almost to 50% of it. And the way you do that is only on residential, you assign the load type to R, which stands for receptacles. But in other, if it's in a commercial building or a hospital or a factory or an office, you're going to assign the appropriate type of load to that particular load, and so forth. Again, because the requirement for the commercial buildings and office buildings for the demand, for the demand calculation is different between a commercial building and all the loads other than the air conditioning. That's the only one that you cannot demand under the code for the residential as being lighting and power load. Now, the system will go ahead and add all these load types and tabulate them down here under the connected and demand load portion of it. So you see that it added all the receptacles down here, and then all the air conditioning is down there. When we allocated the air handling unit to be for heating, it put it under the H load, and here's the 2 kW, and then AC for the condensing unit, and here's the load. So take 100% of the largest of the two and 30% of the smallest of the two. And the reason I set it up that way is just because during the heating cycle, you have the heater and the fan running being used during the cooling cycle. So there's kind of an overlap between the heating and cooling cycle for the same load. Now you can go ahead and adjust that if you want to. That was my preference, the 30%. If you don't, 0001 and enter, and then calculate, it will take it out of your calculations. Okay, so you see here now the two connected. When we demanded at 0, it took out the demand load completely off the connected load. Okay, let's go back to the receptacles and why we put R for all the load in an apartment or in a residential. The code allows us to demand the first 10 kW of the connected load of lighting and power load in a house or a residential at 100%. So the system, again, at 100%, enlarge it a little bit, at 100%, and the result, of course, is the 10 kW. And then the remaining kW, which is 41.4, it demanded for an office building, it demanded that the default is 50%. For residential, it's 40%, so you go ahead and put or type 40%. It's all the demand loads for you, it adds up. And now the connected load used to be 60, or it it is 66.9. Now it's demanded to 40.1. Now the panel values and size would be based on that particular panel. For the demand load of 40.1, the amps are 192, almost 193. If you scroll up to the top or the header of the panel, you see actually I guess my design engineer already preset these, so I'm going to go ahead and take them out. So go to the control panel, go to the panel module, and then go down to the main, and we're going to go ahead and set it on auto. And this one is on auto. It's already on auto. Okay. Close and calculate. It took out the red marking or the red background to indicate to you now you are set on auto and it's not on manual anymore. The system by itself already recommended to you that the frame of that is for 200 and figure out for you exactly the conductor size for you, 1, 3, 3 odds of conductor, and then the ground is number 6 in a 2-inch conduit. Now, and that's based on this particular demand load. Let's go just change, actually I need to put an AC here. Calculate. Okay, now we set up the load type. So I'm going to go ahead and just change them from an R to something else and see what happens to the demand load. So the demand load, if you remember now, it's changed to a type P1. Now, by doing that, it took it off the load type R down here. So now the remaining receptacles went down from 40 to 36.2. And then added the load type 1, our LD1, down here to 5. Now, if I go to the calculated peak demand load, it changed from 40 to 43.2, and then my corresponding amp is 207. Now, if you remember, the panel was already configured for you automatically based on the previous calculations to be 200 frame and 200 main. Now, by changing the load type, it changes it from the 200 to 225 under the frame, and the same thing under the main, and also adjusted the conductor size associated. Now, as we're doing all this in here, in the background, the system is calculating everything with that particular change, upstream, downstream, whatever is affected by that change is been already done for you upstream, downstream, automatically, and update all this information for you upstream, downstream, as long as they are related to each other, okay? So the relationship here is between this panel, it will be the MDP. So if I open MDP, and I go to panel 201, it changed the connected load now, or the demand load automatically for you. The trip amp is 225, and here is the feeder. Now, the other good thing about Powercalc, it already generated the one line diagram for you, which we, in the previous seminar, webinar, we talked in details about the one line diagram. Now, so if I go back to the control panel, and then on the left side, click on the button that says one line. Here's the one line diagram. Here's MDP, our panel 201, here it is. It is connected to circuit number 3 on MDP and is fed by 225 2-pole circuit. The conductor is noted by number 5. If I go to number 5 here, it says the conductor is 3, number 4 odd, and a number 4 ground in 2.5-inch conduit, and it was also shown here. Now, if you go through the whole one line diagram, you see all the other apartments, they're almost the same setup. The only exception is on 202. it has actually 2 units connected to it. So it shows the 2 condensing units connected to it, and also an on-panel eval. Okay. Now, again, if I go and make any change in the design, it will automatically reflect on the one-line diagram, and will update it automatically for you. Other functionality that I'm going to show you that it also becomes handy, especially in what do you do if you have more than 42 circuit in a panel. You can actually specify up to an 84 pole panel. It would be a 1 enclosure, or if you want 2 enclosures and they either fit through or will be a double lug together. We call them a brother and sister panels. So let's say that panel actually 201, we need more circuits to it, or to add more circuits, and that exceeded the 42, and we're going to need more than 42 circuits for panel 201. All you have to do is to go to the control panel, go to the panel module, down here at the panel feature or features, number of poles, it indicates for you the number 42. Say we want it to be 60 spaces, go ahead and type 60, enter, close, and calculate. It will go ahead and expand the panel to 60 spaces. So if I scroll down a little bit, you see that it went on the odd numbers. It went from 41 to, should go to 59. And if I scroll to the right, it went all the way to 60. So now I have 60 spaces in one panel. Now, this became into being that the code allows us to go up to the 84 in one panel. I think it came to us in the code option when the panel definition in the code prior, I think to 2014 again, was the lighting panel definition that it only contains up to 42 spaces. And if you need more than that, you would have to join the panels together either through a feed through or by a double light. Again, the Powercalc has the capability, say that we want to join panels 202 and 203 together and make them one panel. I will go ahead to open panel 202. And go to, again, to my control panel for panel 202 and go to the wizard. Go down again to the panel features. Under the lugs, you see at the pull down menu, there is a single, feed through, and double. I'm going to go ahead and say, well, I'm going to feed it through another panel. It's going to come back here and ask me which panel do you want it to be linked with. And we said we're going to link it with 203. So I'm going to go ahead and link it with 203 and say link panels. Now, oops, I'm sorry, I clicked on it. Now, it says invalid because of the number of poles, okay? So let's go ahead and do it again. I clicked too fast. Invalid panel. Select panel must be not having a parent panel because that panel is already connected to MDP. So I need to take that connection out of the power distribution system, okay? So I need to get out of this, and then get out of this, and then go to panel 202. What the message is telling you that panel 202 is already the child of panel MDP. So you cannot link it because it's already assigned upstream to another panel. You have to break that assignment before you can do it. So I'm going to go ahead and break that assignment. Sometimes the internet takes a long time. It's updating the entire database right now to take that assignment away from panel MDP. it's acting a little bit funny here, so I'm going to actually go ahead and see if I can reload. Still connected. Okay, final. Okay, something on the internet. Now, so now we're going to go ahead and join these two panels together, 201 and 202. So we go back to panel. Okay, I need to go panel 203. And do the same thing. See, this time we do it like in 2 seconds. The other panel took a longer time. I guess it's an internet thing. Okay, so now these two panels are free to be joined together. I'm going to go back to 202 because I want to join 202 with 203. Go to control panel, go to the wizard for the panel module, go to the features, and go to the lugs. And under the lugs, go ahead and say feed through. And then it's going to ask me which one. We want to feed it through to 203. Okay. I'm going to reload. Okay. All right, so you see what happened here. 202 and 203 used to be two separate panels, and now they're joined together, and graphically it shows to you that they are joined. Two. You're going to see that it transferred. Here's panel 202. Here's the load on 202. And then 203, here's the load on 203. So automatically transferred the load between the two panels and made them one panel, even though, so load-wise, they're one panel, but physically they're two separate panels. Usually the engineers or the designers will donate these panels by the left and the right, or 1 and 2. Or A and B, or A, and then the other one would be AA, to know that it is actually joined or has been fed through the panel A, okay? And the loads have been added across from the two panels, so you see that our demand load went from the 42 to 80 demand load, or even the connected load. So now they're electrically or mathematically they're one panel, but physically they're two separate panels that you can work on them independently. Now, this is a very handy feature. Again, if you exceed the 42, the conventional 42 spaces panel, or also to meet existing condition if you're working on an existing panel. Now, this is the voltage drop. So let's go to the control panel and open our panel 201. Okay, so here's panel 201. And it's connected to MDP3, and I showed you how it's been depicted on the one-line diagram, and I showed you if you make a change in any of the circuits or any of the panels or any of the feeders, the changes will carry through upstream, downstream, as this is related to that particular item, or how they've been related to each other. The voltage drop. Why do we have to perform, I guess, the voltage drop? For the maximum efficiency, each machine is designed to operate under a certain voltage. So to get your maximum efficiency and maximum output from a machine, be within plus or minus, as the manufacturers say, 5 to 10% voltage drop. So the optimum energy or the optimum usage of that machine is at the rated voltage. So that machine will operate at the optimum efficiency if you really provide that voltage. But of course, real life is different. There is no way, or it's not that there's no way, it'd be very costly to go ahead to really always going to go ahead and give it the 240, so it gives me the maximum efficiency. Now, there is no code requirement per se or mandated by the code to provide any voltage drop. There's a recommendation in the NAC to provide the voltage drop, and that the voltage drop should not exceed the 5%. And that's from the supply side all the way to the furthest load on that particular circuit. Furthermore, the NEC said, okay, we go ahead and allocate 2% on the feeder and 3% on the branch circuit. So you have to stay within that parameters. It's a recommendation. It's not mandatory. You don't have to really do it unless the building department is going to go ahead and mandate it on you. Now, here in Florida, it's mandated on us through the energy code, entire circuit from the supply all the way to the load within 5% voltage drop. It's not an NAC requirement, it's an energy code requirement. I don't know, other municipalities or other states, how they actually deal with it. But if you look by the Powercalc, let's take a look at circuit number 3. It's 1.5 and it's 2 number 12 and a number 12 ground and half an inch conduit. And in order for us to maintain the 3%, that circuit should not exceed the 216 volts. Feet. Okay. Now, let's say that the furthest load is further than the 216. If it's further than 216, that means your voltage drop is going to be higher than the 3%. But in order for you to keep it at that level of a 3%, the only other choice you have is to upsize the conductor size. So you need to go from a number 12, or maybe from a number 12 to a number 10 or a number 8, depending on the distance. Now, to do that, to adjust the conductor size, again, go back to the control panel, go to the branch circuit wizard, and the worksheet is start with the panel board. So I'm in panel board 201 and start with circuit number 1, but we're going to go ahead and attack circuit number 3. So I'm going to go ahead and select number 3. Okay, and so it listed for me all the parameters for that circuit. It's 2 number 12 and a number 12 ground and a half an inch at 216, or to travel further with that particular circuit over the 216, you need to increase the conductor size. So you go to the conductor, see here the adjustment row, and you click on the conductor size, and we're going to change it from a 12 to a number 10. And we're going to go ahead and, of course, you can go to the next circuit, and so forth, but we're just going to go ahead and demonstrate one circuit. So now I go and calculate and take a look at that particular circuit. All right, so first of all, it changed the background of the conductor size to a red background with a white text. And that's to indicate to the user that the automatic functionality of that particular function has been overridden, and now you're in a manual setup. Okay, now if you go a little bit further to the right, you see that the footage, linear footage changed from, and it maintained for you the voltage drop. So again, to maintain the 3%, you can now go 361. Now, if 361 is not good enough for you or for that particular design, you need to go ahead again and increase the conductor size to the next size up. You go to the control panel, go to the branch wizard, and from the branch wizard, we're going to change it from a number 10 to a number 8, and close. Okay, now with the number 8, I can go about 555 feet, and you can keep on going and going. Now, also, if you notice that when we went to the number 8 conductor, and it adjusted automatically for you the conduit size, it went from 1/2 inch to 3/4 inch, that because the conductor view. Now, another function that associated with the increase of the conductor size for the voltage drop, the code requires you, if you're going to increase the feeder size or the branch circuit size, you have to increase the ground conductor size by the same ratio. So if I increased it by, say, 20% on the branch circuit conductor, I have to go ahead and do the same thing on the ground conductor, is to change it by the same ratio. Now, the system at number 12 to a number 8, so, and the ground was also a number 12 on the original circuit. So since it's the ratio between the number 12 and number 8, it's the same on the ground. But if they were actually two different sizes, by different size, and it will adjust the entire circuit for you based on that particular increase. So I think to summarize what we talked about here is how to set up a panel, how to input the circuits, and how is the KW, the number of poles, and then the circuit type or the load type under the max load cell, and it will display everything for you that associated with that particular load. And then we went to do the voltage drop. With that, I guess I'll leave the last 15 minutes for questions and answers if anybody has a question.
Thank you for your attendance today. Any questions?
Find everything well. Thanks, James.
Ken, I hardly can hear you. Can you just speak a little bit louder?
I said I think you went over everything very well. I don't really have any questions.
Thank you very much.
Actually, I got a question. What is unique about Powercalc's voltage drop?
What is unique by the Powercalc voltage drop? The uniqueness here that we are following a precise engineering, the guidelines of the NEC. And it's quick and it's fast, and there's other things that are associated with that calculations that has always been, I guess, calculated. One of them that I talked about, that when you increase the conductor size, you have to increase the ground conductor size by the same ratio of the increase. You increase the conductor size, it will change the conduit associated with it, and it give you that associated distance with the increase of. So it's almost like a once. Okay, when I change this, I have to go somewhere else to change something else, and something else. They do it all in front of you. Another unique thing in here for people that are energy cautious, the erase, which is energy reduction. It will calculate for you the amount of wasted energy in the conductor just to move the power from point A to point B. Because of the friction and the traveling distance and that sort of things, you actually losing some of that power. It's about 5 to 7% of the power that you start with. You end up with about 7% less of it at the load side, which we will go through that in another one of the seminars. But I guess the main thing here, it's in one place, it will do all the calculations for you, and you will meet the code without any problems. And of course, it will indicate for you the distance. So I guess traditionally that we've always relied on the contractor, and I'm sure that everybody has that note either in the circuit exceeds a certain distance, like 100 feet or 150 feet for a 120 volt circuit or a 20 amp circuit. It's the contractor responsibility to increase the conductor size. Well, I am yet to go into a project to actually the contractor had done that. They don't do it. You show with the number 12, that's what you're going to get. Whether for 100 feet or 1,000 feet, you're going to get the number 12 conductor. This way here with Powercalc, it gave you a design exactly what you want to see in the field. Okay. Any other question?
Yeah, just one more. Why do we have to perform a voltage drop?
Why do we have to perform the voltage drop? I think I talked about it briefly. The machines are designed to operate under a certain voltage and a certain amp. And you have to, in order for you to get the 100% performance out of that particular machine or a piece of equipment, you have to supply that piece of equipment that voltage. If you don't, you actually it's not under equipment. And the higher the voltage drop at the unit of course is going to heat up, and it's always not going to be able to perform the work that it's supposed to do. So also you reduce the life of that particular piece of equipment. So make sure that we are giving that machine all the opportunity it can, I guess, to perform at the rated volt and give us the utmost performance output. And as I said, it's not a code requirement. I think it's going to become a code requirement since we'll start seeing it is required by the energy code is to perform the energy, to perform the voltage drop. I can see it coming probably in the next segment or the next cycle of the NEC, that it's not being there. Can you imagine how much energy we'll be saving if we are losing about 4 to 7% of the delivered power to each piece of equipment? And if you look at it and you say, gee, how how many pieces of equipment that I have, that's a lot of money. If you go ahead into the application as a building, and then how many buildings you have in the town, and how many buildings you have in the state, and then worldwide. So it adds up a lot. So you're going to see that to be mandatory. Any other question? Okay, I guess with that we conclude this presentation. Now, and thank you very, very much for attending. The next one, we're going to really talk about the fault current calculations, do that. And also we might touch bases on the erase module that we have in Powercalc. Thank you very much, and see you next time.